Hi everyone, I'm very happy to be here. It's a special talk for me. I'm going to go down the memory line, how we get to the GitOps idea, how we build Flux around it, and where I'm seeing this movement going forward. Going to start explaining a little bit the context of how we got to GitOps in the first place. So this was very early on. I think Kubernetes was still not 1.0. There was no Kubernetes deployment object or anything. I was at Weaveworks back then, and we were building a SaaS offering for a hosted Prometheus. Right? So we were trying to get people on Prometheus, run it as a service, and of course we tried to run it on Kubernetes. There were back then no Kubernetes installer, no nothing, right? So we had to build our own, build Kubernetes from source code, deploy it on AWS, I think, VMs and so on, with the automation we had back then in place. So doing this exercise of, building a control plane from scratch, deploying apps there, we kind of figure out that Kubernetes allows you to do things easier than systems before. And I think the major shift was declarative versus imperative, right? Everybody here knows Terraform, or maybe before that you work with Puppet, Chef, other technologies, right? Anybody here work with Puppet? Yeah, my kind of crew, yeah. It was not that great. It was what it was, right? It was the right tool for that moment. It was, I think, Puppet was GitOps before GitOps was a word. The problem with, also with Terraform and running infrastructure, running deployments in an imperative way, I would call it, is the third state. The system that you are addressing to, that you are trying to program, does not have its own discoverable state. So you need to keep this third state, right? The Terraform state files, Puppet has its own, database. Chef has its own approach to this. So you can't just look at a system and ask the system, hey, in which state are you now? When you change the system in an imperative way, you run some command on it to install a package, to start up your application, to register your application in systemd or whatever you are doing back then, you need to track all these operations that you've done and store them in this third state that you have to manage. Then, in order to determine what's the next thing I have to do, you can't just ask the system. You have to look at what you did in this history, compare it, and so on. Kubernetes kind of, from my perspective, this is where the biggest shift happened back then, was you can actually ask the system, and the system will tell you exactly what's going on. And it was very fast, right? It has a really good API. You no longer had to guess what's happening. And this allowed, the new era of continuous delivery where you can build on top of this declarative model a way of continuously reconciling the desired state. So instead of poking around and moving from one stage to another, I have a new version of the app, let's see in which stage the old version it is, deploy the new version, then pause. And if the new version, runs into issues or whatever, you don't know. You have to run something again, like a CI job. So we used to do these kind of operations as a one-off. While with Kubernetes, because declarative has this fast API, knows its current state, we can move away from one-offs to having a system that understands itself has self-healing, and we can actually have this continuously reconciling idea. Another big shift back then was this debate between pull and push, right? And I think from the cloud native projects, Prometheus actually encouraged this kind of mind shift. Instead of you having to instrument all your applications, and the application have to go to the monitoring system and say, yes, I'm up, or these are the things that I'm doing currently. The reverse is this: the system comes to the application, discovers the application somehow. Of course, this is the magic of Kubernetes CNI and so on. We have this system that allows other tooling to do the discovery part. It comes to the application and takes from the application the metrics, right? So GitOps was a combination at the beginning of these two shifts. Like, we are now dealing with a system which is purely declarative. We can query it very fast, and we don't need to rely on other things pushing the state. We can do pulling. We can look outside the system, find the desired state, and pull it inside the cluster. And we can make this continuously, right? Now, when we started with Flux, we had some misconceptions, let's say. We were probably way too, I don't know. We thought everybody knows Git. Like, everybody should know Git, right? You are a developer, you definitely know Git, so it's easy. We are going to replace kubectl with the Git CLI. It turned out, I don't know, even if developers know Git, they don't quite like it, or they don't quite understand it that much. So maybe Git is not the perfect tool to replace kubectl, but that was the idea back then, right? Another thing we assume is that if we teach app developers this new paradigm, like Kubernetes being declarative, Prometheus discovering your apps, and everybody, all the developers will all of a sudden love to do operations. They'll love it, right? It's no longer, you don't have to write like Puppet templates or learn a new language like tooling like Terraform. It's like, they'll love operations. It's purely declarative. It's YAML, like they do with configuration all the time. It will be great. It turned out after so many years, everybody hates it. So maybe we were overreaching. So how we got the first version of Flux, I joined, we worked in 2017. Flux was already built inside 1 year before. The first version of Flux was very simple. Remember, back then there were no Kubernetes CRDs. That was not the concept of extending Kubernetes with custom resources. I don't think the deployment controller was there. It was called Replica. How is it called? Replica controller, right? So in the first version of Flux, how this thing was designed was, we assume you will be able to deploy Flux on every cluster as a Kubernetes pod, and you configure through arguments and environment variables, like any application, where the desired state is. You'll give it the Git address and a SSH key, and once you have Flux on all your clusters, Flux will go to the single repo and synchronize everything everywhere. There were some limitations to this first iteration of Flux. One major limitation was, if you wanted to change anything in the configuration of Flux, you had to change its deployment, its pod. The second major limitation was, and back then we didn't feel like it was a limitation. Later on we did. One cluster could only follow one Git repository, right? So, because we thought, why wouldn't you store everything in one Git repo? Kubernetes is a monorepo, right? We were doing also other applications, everybody in our world was monorepos. So nothing can go wrong. You can put everything in a repo, everything should turn fine. And this worked for a couple of years. GitOps was no longer, something that 5 people knew about. It started to gain traction. Other projects came into being. Argo CD, there was a spin-off of Jenkins called Jenkins X. Does anyone remember Jenkins X? Had anyone used Jenkins X? Wow, okay, yeah. But with, like all new technologies, there is this graph, like you have an idea, there is, let's say, a project that shows that that idea can be successful, then it's an explosion of options, right? There were, at some point, I think we had a list, like there were like 6 tools at least that were trying to do GitOps, right? Now we are in a stage where it's Flux, it's Argo, and I don't know, anything else comes in mind? Do you use anything else for GitOps? There are some products from the cloud vendors. I think there is a Google config sync, stuff like that, which are very specific to a cloud vendor. But after so many years of GitOps, it was that explosion, a lot of tools, a lot of experimentations, and then, this is how the market works in the way. There are 1 or 2 winners, and everything else is lost in time. So yeah, we got to this stage early on where we had these limitations. Things were starting, we've seen Flux being adopted in production systems. And the next thing we've built in Flux, which was, let's say, quite revolutionary back then, was the idea that in order to change the system, you have to commit something to the Git repo, right? So if your app developers build a new app image, they'll have to open, let's say, a pull request or commit directly to this monorepo, the config repo, and bump the image version, right? Early on, the feedback was developers don't want to go to this config repo and do this thing manually. What if we want to deploy 10 times per day? I'm going to create 10 commits changing from version 1.0.1 to 1.0.2 and so on. It's redundant, right? We don't want to do it. So we've built in Flux a thing called image automation, which basically you say, Flux, scan my repo, find the latest version according to some policy, let's say a semver expression and so on, and if a new version is pushed to the repo, commit that to Git, and maybe open a pull request, someone merge it, or you merge it automatically, and that's how you do continuous delivery. Because if you don't have any kind of automation on that side, the continuous delivery involves a lot of humans dealing with YAMLs in the Git repo. So that, after we've built image automation and that gave app teams velocity into what they're doing, after that we've seen a major adoption of GitOps and Flux, of course. And in 2019, we donated Flux to CNCF, and that's when things got really big. Also, the competition was very serious. So we were hitting all these limitations. Flux was built as a monolith. It had code in there that dealt with all the Git operations. It had code in there that dealt with the desired state, changing the cluster state, talking to the Kubernetes API, and code in there that would scan registries, connect to these external systems, and so on. So the next evolution was rebuilding Flux from scratch and with only the GitOps concepts being the same. But the software completely changed. And not many projects are successful doing a whole rewrite. I think we were. I'm still here. I'm talking to you. So Flux version 2, we started five years ago, a complete rewrite with a different mindset where we we separated and we created Kubernetes controllers with CRDs, and these controllers are dedicated for their scope. For example, we have in Flux a thing called source controller. This controller only deals with going to the Git repo, going to OCI, registries, and so on. And it's scoped also in terms of security, in terms of RBAC. That controller cannot change the cluster state. And there were like two reasons why we did this split. One was for, of course, security concerns and all of that. We also wanted to have a diversity of, you know, maybe you have more than one Git repo where you store your things. But we also wanted to make contributions easier. When you have this monolithic approach, it's very hard. If you change something in the source code, it can affect so many parts. It's very, very hard. It was very hard with Flux One at some point to get contributions in. So we wanted to, you know, allow people to come with their ideas into the Flux project and expand Flux that way. So separating Flux into many controllers, which everyone with each with a dedicated scope and you know, well-defined API. After we've built it, we kind of tripled our number of contributors. The community grew a lot, and we've seen huge adoption also in, you know, enterprises, cloud vendors who started to use Flux internally for their own deployments, and also offering Flux as a service to their users, like Azure, for example, offers Flux version 2 to users. Another major thing we've built in Flux version 2 was getting the cluster bootstrap, having this as you know, a really well-thought process that had a good user experience. And we created the Flux CLI that has a single command called bootstrap. You run that, and everything, you point it to the cluster, and the whole cluster gets bootstrap, all the applications, all your cluster components in the right order, with dependencies between them, and so on. You can also create the main Git repo for you. It can then allows you to connect from this repo to any other sources of truth. And we also made the decision that Git should not be the only way you can define the desired state. And we first added as an option to Git S3 and buckets as another option. Like people say like, okay, but S3 is not version. Why would you do that? We did this integration with buckets, and it's not only about AWS. Any kind of S3 compatible API works here due to high regulated systems. There are high regulated industries. There are places where, okay, Git is part of the development workflow, but when it comes to production, the only place where something from the cluster can access is a database and a bucket, right? So that was the first implementation where we say, okay, you can build some kind of automation in Git, push to the bucket, and then Flux will connect from there, and Flux will never reach out outside your trust zone. The issue with this process was that when you run the bootstrap command, we need access to your Git repo to push the Flux manifests. Because in Flux version 2, the idea was if Flux is made to deploy other applications, Flux should be able to deploy itself. And that was one of the design principles. So when you run bootstrap, we commit all the Flux manifests to the repo, and Flux then takes its desired state from there. What that means is that after the cluster bootstrap, you don't have to touch the cluster anymore. You don't need Kubernetes API access. You deploy all your apps through the desired state, but you can also upgrade Flux, make changes to the whole system through Git, and Flux will upgrade itself and change itself, more like, you know, how Chrome does it, or other browsers. We wanted to bring that kind of automation into the system. And it was a really nice way of dogfooding our own technology, right? If we can, Flux version 2 is quite complex, has a bunch of CRDs, 14 CRDs, 6 controllers, now there are 7. If we can manage to orchestrate all of that, then any other application will be easy. Okay, so we got to this stage where Flux can take things from the desired state and deploy the app. Now the next problem we had to solve was, okay, the new version of the app comes into production, everybody lands up on the new version. What if the new version is broken, right? So we extended Flux with another project called Flagger, which is part of the Flux project. It's under CNCF, and comes with this idea of progressive delivery. The idea is when you change the desired state, and let's say you push a new version on your app, instead of all your end users landing on the new version, you can define a policy. Here is the policy is called the canary. It's a custom resource. And then Flagger can talk to your ingress, your service mesh, whatever it is there in front, to shift traffic between the two versions. So we kind of added a new layer that gives developers more confidence in a way that it's okay to fail, it's okay to do a bad deployment, because you can easily catch it and you don't expose everything to the end users. And also Flagger can quickly do a rollback without you having to go in Git and change the files. So until here, it was almost everything about Git, and Git was basically part of your production system, unless you use the bucket. And 3 years ago, we came out with this idea where, what if we adopt the Open Container Initiative, we build an OCI artifact for Flux, and Flux, like Docker, now has a push command, a build command, and so on. And we unify everything under the registry. And the idea here was, in order to run a Kubernetes cluster, you need a container registry, right? It's how your apps get deployed. So what if we reuse the container registry to also store there all your configurations, your Helm chart, the whole desired state. So it's app code plus configuration plus policies. Then you can sign everything in the same way. You can verify everything in the same way. And then clusters become more reliable. If GitHub goes down or GitLab, both of them go down pretty often, I would say, right? If you adopt GitOps, you are basically having these systems, even if you run your own Git instance, you have these systems as a dependency of your production cluster, right? And it's quite hard to, secure all your Git servers and so on and make it part of production. With this approach, basically, you build some CI that runs a Flux push command, maybe runs a cosign sign command, and so on. And you can reuse your current CI workflows and deal with configuration in the same way you are dealing with containers today. And we've seen this adopted by banks and other large institutions because they like the idea of having a single store for code and configuration, being able to sign all things in the same way. And Flux has integration for verifying all the things. Of course, we had integration with Git. We can verify Git commits and so on. But the signature of a Git commit is tied to a human, the one that has committed. In this new world of OCI artifacts, the signature is made in CI, is part of your system. You can also have attached an SBOM, so you know what was the environment where that configuration was built and so on. So it gives you a better understanding of the whole workflow. Okay, so the last stage of the Flux evolution and how we see GitOps is at control plane, we are developing this Flux Operator, which is also an open source project, is built on top of the Flux APIs. It tries to solve a lot of issues that we've seen over the years with Flux. For example, giving you a declarative cluster bootstrap. And it looks like this. Basically, instead of running the Flux bootstrap command with all the combination of flags and so on, you can write a custom resource and you can configure Flux in any way you want. And it also allows a pure bootstrap from OCI Artifacts, right? So it's no longer, the Flux bootstrap command is also tied to Git. When you use the operator has no opinion. You can point the operator to a registry, you can point it to an S3 bucket, or you can point it to Git itself. So there is no, hard coupling anymore between this bootstrap process and the source of truth. That was the first thing we've built in the operator. A second thing is dynamic resource composition. And we've introduced this API called resource set. The idea here is that one of the most requested feature in Flux in the last year was, I don't want to merge changes and then look at the cluster and see what's going on. I want to have the same workflow as we have now for code, where you open a pull request, CI does stuff, runs my tests, maybe builds my container. And I don't want to merge anything. I want Flux to deploy whatever was built in that pull request on on a preview cluster or something like that. And with this API, we allow you to tell Flux Operator, hey, scan my pull request if it has the label Flux Preview, take what's in there based on a template that the cluster admin has created, that can spin up a new cluster using cluster API or use a namespace in an existing cluster, deploy everything from the pull request there, then go back to the pull request and tell people, this is how you can access your app. Maybe now you can start your end-to-end tests, and we have these integration points and so on. And we've seen like major adoption of this new API. And here is where we are putting a lot of effort, and we are integrating with more Git services and so on. This is how a resource set looks like. It has an input provider where you define where your GitHub repo is, and it should scan pull requests. It also works with GitLab, works with Azure DevOps, and we keep expanding it. And this is how the templating looks like. It's a little bit of Go templating with some magic around it to make it simpler. Okay, last thing, AI. So after we've built the operator, we decided, okay, now we have these top-level APIs built on top of Flux. Now is the right time to expose them to AI systems. And it's also part of the Flux Operator project. It's free. You can use it with your own AI systems. It has, so the first role when we've built the MCP server, what we've seen is that especially Claude and other models are really good at Flux APIs. They really understand them. They can generate all the Flux configuration for you, especially if you feed it the latest Flux docs. So the MCP does that, exposes the latest APIs in a, let's say, a more compact form, or more friendly form for the AI to understand how Flux works and all the other Kubernetes objects. So it is really good for generating content. But where we see the power of using the MCP is more around troubleshooting and root cause analysis. And we've seen large Flux users using the MCP during incidents and so on with great success. It will not be perfect. It's AI. It can't be perfect. But it can be a huge shortcut to finding the root cause in complex systems. This is how it looks. You can run it locally. We are now working on running the MCP server in cluster with OEDC authentication on top of it. As I said, it's really good at incident management. And we've built some MCP tools specific in the server for debugging and incident management. So instead of, the Flux MCP server is not running kubectl commands. It's talking to the Flux APIs and gives the AI a form of the responses that it gives back are compacted, and it also has hints for the AI to move forward and find the next problem in the chain and so on. This is how you can do it. This is how it looks all together. There is a demo on the website. You can try it out. One last thing, 30 seconds about security considerations. You have to be careful with this stuff. Like what we built in the MCP server was, it cannot query Kubernetes secrets. So even if it can touch everything in the API, but when we serve the secret back, there are no secret values, only the keys in your Kubernetes secret. And this is because it will definitely go into model training if you don't know what you're doing. But of course, if you put secrets in your deployment environment variables, good luck with that. And we also build a read-only mode into it, so it is really good. It can help you fix things, but it can also delete your whole cluster. So it has this read-only mode. I invite you to try it out and give us feedback. It's early on. We've seen a lot of adoption in this space, enthusiasm, but yeah, there are many, many ways on how you can, bring down your whole system if you don't know how to use it. Thank you very much.